Hi everyone, hope you're doing all right. Today we're going to get started into our next concept, which should be a bit of review because we've talked about this back when we were looking at our trig ratios, sine, cosine, and tangent. And that is the idea of the radian measure of an angle. So, long story short, there's two ways to measure an angle, degrees and radians. Before getting into what those are, I'd like to give a little, analog to that, which is let's talk about temperature. You know that in your everyday life, you're going to encounter two different scales of temperature. One is degrees Fahrenheit, don't ask me to spell it because I always misspell it, and degrees Celsius. Now, each of them have different scales. I say scales meaning we know that in Fahrenheit, water will freeze at 32 degrees, and it will boil at 212. Compare that to Celsius, where it freezes at 0 and boils at 100. Wow, Celsius has a lot friendlier, easier looking numbers to memorize. So then, why does Fahrenheit still exist if Celsius is better in every way? Well, there are some ways in which Fahrenheit is a little bit better. The Fahrenheit scale was developed by a scientist named Fahrenheit that was based on the freezing and boiling temperatures of certain brine solutions. The upshot of that is, while Celsius is very good for scientific measurements and things in labs where you're basing it off of water, Fahrenheit is a scale that's better suited for the human body. In other words, weather reports, let's say, if they're reporting weather in degrees Fahrenheit, you have a larger range of numbers to deal with, as opposed to Celsius. They usually have to use decimals in order to get like the fine-tuning amounts. So the point here is that we have two ways of measuring the same concept. Some have benefits, some have drawbacks. In that same vein, we've got two different ways to measure angles. There's the way you're totally familiar with that you've seen and used all the time, which is the degree measure of an angle. And then there's this other concept, which is the radian measure of an angle. Neither of them are too crazy to understand. Let's go with degrees first, because we understand that. A degree measure of an angle is really simple. You've got a circle, right? If I cut that circle up, and I said, let me just take 1/360th of that circle, just that little bit of it, that amount, if I go from the center, the angle I have to open up to measure 1/360th is a degree. And that's all a degree means. 1 degree is 1/360th of a circle. So think back to that degrees Fahrenheit, degrees Celsius idea. Degrees are kind of an arbitrary number, sort of like Fahrenheit, in the sense of you got to memorize these weird numbers, like a quarter of the circle is 90 degrees. 3/4 of the circle, that'd be here. 3/4 of the circle is 270 degrees. The numbers aren't very friendly. The only reason degrees seems friendly and nice and easy is because you've used them your whole life. But degrees does have some benefits, being anytime we're measuring angles, we are usually using whole numbers or pretty close to whole numbers. You'll find that's going to be different in a radian. So before we can talk about how many radians there are and things like that, let's talk about what it means. I'm going to have my circle here. And as you know, every circle's got its center point, and it has a radius. Here's the definition of a radian. A degree was 1/360th of a circle. A radian says, let's take this radius here. Now imagine if I got a piece of string and I measured that radius, and then I took that string and I wrapped it around the outside of the circle. So if I took this radius, I could wrap it around the circle up to about here. And let's say this length of the circle, if I would actually take a tape measure and measure the outside portion of it, has the same length as the radius. The angle that would be required to open up that portion of the circle, right here, that measure is known as 1 radian. So in this case over here, my theta is equal to 1 radian. Okay, so that's what a radian is. You'll notice 1 radian is a lot bigger than 1 degree. So what's the conversion between the two? Well, let's think what we know about circles. In particular, let's talk about what we know about the circumference, because this is the outside of the circle, right? How many times can I wrap this radius around itself? Well, let's see, I've got 1 there. I could wrap it again twice. That would be another radius here. I could wrap it around a 3rd time. And if you look, I'm not quite 3. There's this little extra. So how much more can I do? I know I've got 3 radians and a little bit, but how much is that little bit? Well, like I said, let's think about circumference. We know that an entire circle's circumference is followed by that formula. The circumference is equal to pi times the diameter. Well, I know a diameter is just 2 radii, so let me just say that's equal to pi times 2 times the radius. Now let's talk just about how many radians I can fit in this top half of my circle. Well, that would be half the circumference. I'll take half of that, and then let me take half of that. Well, that would mean that half circumference, half a circle, has, well, if I take half of this, that would just be r times pi, the radius times pi. In other words, if I take my half circle and divide it by the radius, I would know how many times does the radius go into the full circle, or into the half circle. And as you see, it's pretty easy to just prove that there are pi radians in half a circle. Now that's a lot for me to throw at you. Let me explain that a little bit more. I have my circle, and now I have this concept known as a radian. A radian is the measure of an angle such that, that's probably a little too small. That's a little bit better. A radian is the angle measure required such that it opens up a portion of the circumference exactly equal to the radius. So again, I'm not talking about a triangle here. I'm talking this actual, what's known as the arc length. We'll talk about that in another lesson. The actual length around the circle is equal to the radius. If I then copied that angle again and I said, ooh, now I've got an angle that's 2 radians. There's no symbol for radians, by the way. You just say radians. If I open up an angle that is 2 radians, it traces out a portion of the circle equal to 2 radii. And if I said, okay, now let me open up a portion of my circle, let me measure 3 radians. As you guessed, that means I'm tracing out a portion of the circle that is equal to 3 radii. And now, if I were to extend it so that way it covered the entire half of a circle, well, I would need to take my radius and multiply it by pi. That's the length of it. Or if I took pi radians, so that's 1 radian, 2 radians, 3 radians, 3.141592653 radians, I would get the half the circle, meaning a full circle has 2 pi radians. The same way a full circle has 360 degrees. It's just a measure of angle opening. Same way I could say, oh, a meter has 3.2 feet. They're both just abstract concepts to measure distance. How we define how big those things are how they relate to one another. So hopefully you've got an understanding now, at least, of how big a radian is. Why would I ever want to use this angle measure that's got pi involved in it? The short answer is the fact that When you get into higher level math, especially in Algebra 2, but even up in collegiate level things and calculus, the math is a lot friendlier when you measure with radians than with degrees because of this relationship between a radian, pi, and the radius. It winds up making math friendlier and a little bit nicer to deal with. That's not to say it's going to take a while for you to, get used to it. Like if someone told me there were, if I asked how big of an angle do you need if I was constructing something, right? I'm hoping they're going to say, oh, it's a 45-degree angle because I understand that measure. I say, oh yeah, it's like that much. Okay, cool. But if I said, how big of an angle is it? And they say, oh, it's 1.75 radians. I don't know what that is off the top of my head. I'm going to need to do a little conversion to get it into degrees, which is the measure I use. The same way, if someone asked me, how far is your house from where we are right now? And if someone said, oh, it's 2.8 kilometers, I've got a rough idea of what that means, but I'm going to do a conversion back to the imperial system in my head to say, okay, that's this many miles for me to understand it. Or if someone who's bilingual, oftentimes if they hear something in their second language, they'll kind of have to translate it in their head to their native language to make sense of it. So I recognize that this isn't going to be an impulsive thing. It's not going to be something you immediately understand, but just be aware that a radian is just a different measure of an angle. 1 radian is a lot bigger than 1 degree. So now let's talk about how you get in between the two of them. Let's say I had an angle, and we're going to start off real easy. Let's say I've got a 90-degree angle, like that. Now again, I'm drawing it in terms of a circle, the unit circle here, so it's a little easier to understand, but this could just as easily not be an angle in a circle. So I've got a 90-degree angle, and I want to ask, how many radians is that? Here's the best way to do it. Set up a proportion. I've got 90 out of my 360 possible degrees. I want to know how many radians that is out of, and if you remember, there were 2 pi radians in a circle. Just remember, pi is just a number. We're writing it this way, that way we can actually write the idea, but pi is 3.14-ish, so that means there's 6.28 radians in a circle, so 6 1/4 of that angle measure. So I've set up my proportion. Now let's just cross multiply it. 90 times 2 pi would give me 180 pi is equal to 360x. So let me divide by 360. And you'll see that x is equal to 1/2 of pi. That makes sense, right? We said that this half of circle, that measure was known as pi radians. So then I would expect half of that to be 1/2 of a pi. Let's do on this a little bit less friendly. Here's a 60-degree angle. Give it to me in radians. Again, set up a little proportion. 60 over 360 is equal to, I don't know how many radians, out of 2 pi total. Cross multiply. 360x is equal to 120 pi. So then x is equal to 120 over 360 pi, which means x is equal to 1/3 pi. Again, that should make sense because if I have my half circle, 60, 60, and 60 makes up 180 degrees. So that little angle in there is 1/3 of what pi would be. You may notice there's a little bit of formula showing up here. I'm going to do one more that's just not friendly at all. Let's say I've got a 47-degree angle, and I ask, how many radians is that? The way you would typically do it is, again, we're going to start off still by just setting up a proportion. I have 47 out of a possible 360 degrees. That's equal to a certain number of radians out of a possible 2 pi. So let's cross multiply. Let me just do 47 times 2, which should be 94. Oops. 94 pi will equal 360x. Now let me just divide by 360. X is equal to, I'm just going to do 94 divided by 360, which gives me 0.26, and then the 1 repeats, times pi radians. And if the question said round your answer to the nearest hundredth, I would just do my 0.261 and multiply it by pi. Oops. And now I'm getting 0.82 radians as my answer. Okay, let's talk in general. Let's make it a little bit friendlier. This proportion will always work. Let's talk about a little bit of a shortcut now. Okay. Let's say in general, I have some angle which is measured as theta degrees. And I want to know how many radians is it. Let me set up that same proportion. Theta, the number of degrees I have, out of a possible 360 degrees is equal to the number of radians I have out of 2 pi possible radians. So then cross multiplying, I have 2 pi has always been multiplying by whatever my theta is. And that's going to equal 360 times my x. So then, I then divided by 360 every time, and I would have had x is equal to 2 pi times theta over 360. We can simplify this fraction a bit. X, which again, remember, x is my angle measure in radians here. Two divided by 360, well, that would give me 1 over 180. Now that fraction is still multiplied by pi times theta. So in other words, if you have some angle measured in degrees, if you just take that measure and you multiply it by, I can even simplify that further, pi over 180, I would get 60 pi over 180, or as we had as my answer before, 1/3 pi. So, if you have an angle measured in degrees, multiply it by pi over 180, and you'll get the radian measure. What if you want to go backwards? You just divide it. In other words, visually, I hope you're getting the point, you can visualize how big, because if I said an angle measure was 1 degree, in your brain you go, whoa, that's really, really, really tiny. Hopefully you're getting the point, if I say something's measured as 1 radian, your brain's saying, okay, I know how big the radius is. If I took that radius and wrapped it around, okay, that's a pretty sizable portion of it. Let's say that there is the measure 1 radian, because this is r, and then the length around the circle here is r as well. Again, I'm talking about the length of that section. If I placed like a tape measure and wrapped it around, I'm not talking about the measure of an arc as we've done before in degrees. I'm not talking about that. I'm literally talking about the length of it, the measure of it. So, how many degrees is that? Well, let me take 1 radian and divide it by pi over 180. 1 divided by pi over 180. Beep, 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 beep. I just type it right in. And we're getting that 1 radian is about equal to 57 degrees. Obviously, because there's pi in there, it's an irrational number. It's not going to be friendly. But that's about how big it is, about 57. In my head, I always rationalize it to about 60. That's a very rough estimate, but that gives you an eyeball of how big a radian is. Moving backwards and forwards between them is just as simple as either this rule. If you want to go from degrees to radians, well, radians is bigger, so multiply your degree measure by pi over 180. If you want to go from radians to degrees, divide your number of radians by pi over 180, and you'll get the degree measure. If you can't remember that, always just set up your proportion. How many degrees I have over the possible number of degrees, how many radians I have over the possible number of radians. The problems we're going to do are mostly just questions that require us to measure things in radians or in degrees. We don't have to get too crazy in there. But the reason I'm giving you this, the reason you need this tool, is because a lot of problems we're going to work with in the next concept, which is arc length and sectors, they're going to have angles measured in radians, so I just want you to be prepared. So let me know if you got any questions on it, and if not, if you feel okay, move on to the next one. See you guys soon. Stop.